All right, we are going to be moving into section 3.3. So over the next two videos, we're going to look at some basic graphing techniques that we need to be aware of. So what I decided to do is in this first video, we are going to look at what's called the graphs of basic functions. And so we've looked at some graphing already. We talked about how to graph like lines and graph things like circles, but there are some other popular functions that are out there that we need to know how to graph and what they generally look like. So I thought the best approach to this would be is I'm going to pull up and we're going to work through some of the popular functions that we've talked about a little bit, but we want to see what the graphs look like as well. So on this first one, we would like to graph f of x equals the absolute value of x. Now, since some of y'all may not know what this graph looks like, what I will do today is I'm going to treat this like some basic plotting points. And so as you can see over here on the left, I have created a little grid that I want to fill out. Now, we've done this before, but I want to remind you that usually when I plot points, if I can, which this is one of the ones you can, I typically like to center my graph around x equals 0. So of the 5 spots I need to fill in, I'm going to let 0 be my middle value. And then I'm going to go equal distance in the negative and the positive direction, which means if I want to test -1, I'm going to test +1. If I want to test -2, I'm going to also test +2. And that's typically how I set up my plotting points. Now, these 5 values, you now need to plug into the function that we're working with. And so remember, all an absolute value does is take the positive of the number. So if we apply the absolute value to all 5 of these numbers, you will get 2. Hang on one second. Come on. Hang on one second, y'all. My pen's maxing. One second. Back in. There we go. Sorry about that. Yeah, my pen decided to spaz out for a second. So once again, taking the absolute value of everything, so you get 2, 1, 0, 1, and 2. And remember, what this is doing is it's creating points that you're able to plot on the graph that you see to the right. So all I did right next to it is I wrote the 5 points that we're going to plot. And so I'm going to plot all 5 of these. So -2, 2 would be right here. -1, 1. 0, 0 is right in the middle. 1, 1. And 2, 2. And what you'll notice if you look at this is that it doesn't have any kind of curve in it. Instead, what happens is this becomes 2 straight lines and thus becomes a V shape. And so anytime that we work with absolute values in this class, we will graph a V shape where the bottom of that V is at the origin or the point 0, 0. The second kind of graph you need to be comfortable with is a square root graph. So similarly, I'm going to plot some points and figure out what the shape of a square root graph looks like. Now, this one's a little bit more difficult because you can't just pick any numbers you want because we don't want to deal with the imaginary unit. So we're not going to take the square root of negative numbers. So what I'm going to do instead of 0 being in the middle, I'm actually going to let 0 be my starting point because the square root of 0 is one of the easiest numbers to find. And then filling in a couple of more, I'm thinking in my mind, what square roots are really easy? Well, I know the square root of 1 is easy to find, the square root of 4, and the square root of 9. Because if I take all 4 of these values and take the square root of them, you will get 0, 1, 2, and 3. And what this does, once again, is creates points that you're going to be able to plot on your graph over here to the right. And so if I were to plot all 4 of those points, you would have 0, 0, 1, 1. And you may at this point think it's going to be a line, but when you go to 4, 2, you'll notice that the graph starts to curve. And then 9, 3 is up here. And so if I play connect the dots, this one I missed a little bit, but it's okay. You pick up a graph that mimics what a square root graph looks like. So going forward, whenever we work with square root graphs in this chapter and in this class generally, this is the basic shape you will look at. It starts at 0, 0, and slowly increases to the right that forms a square root graph. All right. We've looked at parabolas, so we've seen an x squared graph, but what about an x cubed graph? All right. So for this one, it only gave us 3 spots to work on, but I'm actually going to maybe add one more if I need to. So typically, once again, no issues with an x cubed graph. So what I would typically think is, well, let's go back to my idea of centering 0, because there's no issues with cubing numbers. And then if I go equal distance each way, you get -1 and +1. Well, once again, if you take these 3 values and you plug them in, so we're going to cube them, -1 times -1 times -1 is still -1. 0 cubed is 0, and 1 cubed is 1. And what this does is it gives you 3 points to begin your process. So if I plot -1, -1, 0, 0, and 1, 1. Now the problem is that if you look at those 3 dots, you're going to assume that it's a straight line. So my suggestion would be to figure out one more point, because this should not be a line. This does not fit the form of the lines we covered in chapter 2. So I'm going to extend this one more, and I'm going to put a 2 here. Well, if I cube this 2, just like I've cubed the other numbers, you will get 8, which forms the point 2, 8. And so if I go right 2 and up 8, it's going to be way up here somewhere. And you'll notice that at least on the right-hand side, it shoots up really quick. Well, what you'll also find out is that it does the exact same thing in the other direction. So it's not really a straight line. Once it gets through this first point, it shoots down pretty quick. And so this fits the mold of what an x cubed graph will look like. That's why you can't always just trust 3 points around the origin, because sometimes you'll mistakenly think it's a straight line when it's not really a straight line. All right, and finally, the last thing I want to make sure you're aware of is that we will also see some graphs that you're used to, like x squared, you might know is a parabola. But what we'll also have to be comfortable doing is looking at graphs on restricted intervals. So on this last problem for this video, I want us to graph x squared, but only between -3 and 1. And you'll notice that the -3 has an equal sign, and the 1 does not have an equal sign. And we'll get into that in just a minute. Well, according to this, it's saying that I must start at -3 and I must end at 1. It's giving me the beginning and the ending. And so if I fill in the middle, that would be -2, -1, 0. And I'm going to take these 5 numbers and I'm going to square each of them to fill in my chart. And so -3 squared would be 9, then 4, then 1, 0, 1, which creates the following 5 points. Go. Sorry, took me a second. Now, go back to your interval. You notice that on the -3, there is an equal sign. So as we've learned about graphing is that when you have an equal sign on your interval, this one will get a closed dot. On the other one, since the 1 does not have an equal sign, you might remember with your graphing, this means that you're going to get an open circle. And so when I plot these points, so if I begin at -3, 9, which is way up here, this one's going to get a closed dot. Everything in the middle is nice. So -2, 4 is a regular point, -1, 1, 0, 0. And then when I get to the end point that did not have the equal sign, the point 1, 1, it's going to get an open circle. And what ends up happening is that I only want to graph between these 2 points. I don't want to go beyond. So I'm going to graph straight down, and I'm going to stop at the left and right endpoint. And that would be a picture of an x squared graph that is stuck between -3 and 1, and we got our open and closed circles done correctly. So this is just the first half of section 3.3, just kind of going over some basic graphs that maybe you aren't as familiar with. In the second half of this video, we're going to move into an idea called piecewise functions. Those are a little bit trickier, so I'm going to put those in a separate video.